Hey guys, welcome to AlgoYogi, and let's solve range sum of binary search tree. And the description is basically simple. Given the root node of a binary search tree, and two integers low and high, return the sum of values of all the nodes with a value in the inclusive range of low and high. So given this binary search tree, whatever values in this binary search tree lies between low and high, we will be adding them up and returning. So simply, if I change the view here, in this binary search tree, what is our low? Our low is 7 and our high is 15. Now, what are the values that are basically in this range? 7 and 15, and inclusive, by the way. So we have 7 here, this value. We have 7 here. We have 15 here. We have 15 here, and we have 10 here. 10. So if we are adding all of them up, we get 32, which is 15 plus 10, 25, and 7, 32. Now, see, it's fairly easy problem. We just we are basically maintaining a variable, and we are iterating over the entire subtree, entire tree, and we've already seen a lot of ways of traversing the entire binary tree or binary search tree. There's a in terms of traversal, we can just traverse both of them in the same way, and add all the value and make a check, like if that value is within that range, we just add it to our variable, some variable that we're going to return in the end. But the trick here is it's a BST. It's a BST. So if it is a BST, then we have to optimize it, right? Well, otherwise, what's the point of asking the question on BST? They could have just generalized on a binary tree, but no, they asked it on our binary search tree. And in binary search tree, we know the answers are mostly in big of log n time complexity, and to achieve that, we have to do the pruning. So how will I do the pruning? When I'm calling this, basically my method on my root, and I'll check if this value is in my range, low and high range. If it is, add it to the answer. If not, then let's do the pruning and call it on either left or right. And we might call it on both, actually, because there might be just all the values on within the range. However, like if it is not the case, but like in a best case scenario, then we are doing the pruning would be checking if my root value, which is 10 here, if this value is greater than my low, if this is greater than and equals to low. So let's not just call it equal, let's just do low. What does this mean? This mean then left side in BST, which is all these values, will be lesser than 10. So this is the range where, so there are values. If this is 10 is greater than my low, that means there is a range in 10 and my low, between these two, there is a range where there might be some values. I want to add it to my answer. So that's why I will have this condition and only make call to my left subtree if that is true. So if my root dot value is greater than my low, that means values between my root value and the low needs to be added. So call the function on left, call on left. And same way, if my root dot value is less than high, that means what? If it is less than high, there is a range between high and the root value. Those values needs to be added to my answer. So if what I'm basically trying to say is, honestly, the pruning needs to be done logically, and the logic is simple, which is just checking if I really need to visit the left side whenever necessary. Sometimes it might be necessary, we want to visit both the sides when everything is just in the range, however, the point of asking a BST here is we want to show the interviewer that we do take care of the fact that this is a BST. So writing the answer simply, let's have a variable that we were talking about to store the value. Let's call it answer. Answer would be just initially 0. We don't add anything, and then we're going to define range sum, calling it on root, and if root is none, then we just return. If root is not none, then what we want to do, let's check if root.val is greater than equals to low and root.val is less than equal to high. If you're a Hindi speaker, you would know what raat is. Why I'm saying that? Then what do you want to do? You want to add it to your answer. That is root.val. Now let's do the pruning. We're going to call it using the pruning. How? If root.val is greater than low, that means there are values between low and the root value that needs to be visited, and where are you gonna find those values? You're gonna find those in the left subtree, right? So you call it on left. Dude, that was not very good. Okay, and the same thing happens on the right side. But right side, we're gonna check if the root value is lesser than high. That means there might be some values on the right side that needs to be visited. Okay, not high, left. Oh, sorry, not right. Okay, and if that's the case, we will call this function and just return our answer. And return answer 0. Honestly, a lot of people just write they don't prune it. They don't have these conditions. They just call it on left and right, and simply just be done. So remember, if this is a BST, you might want to do that. Otherwise, your interviewer won't be very happy. He will be happy that you solved the problem because it will be accepted, because it's pretty, yes, it's root, and it's root. Okay, and let's submit it. My mouse isn't working very well, but anyways, okay, it's accepted. And the time complexity would be best case. Best case will be big of log n, and worst case big O of n. We are right the worst case, but in this case, because we made sure we are doing the pruning, let's write it log n. And space complexity would be just big O of h. It could also be equal to n, or right. Okay. Now let's go back to our AlgoYogi and mark the problem solved. And this tree progresses on the smooth boost. I don't know what it is. But anyway, see you guys later. Bye.